Good evening, everybody. First, please make sure that your video and audio are off so as not to disturb the presentation. Thank you. Welcome to the Jackson-Josephine County Small Woodlands Association's webinar, Weather Patterns for Fire Season 2021. My name is Jerry Burke, and I serve on the board of the Jackson-Josephine Small Woodlands Association, which is a chapter of the Oregon Small Woodlands Association based in Salem. Thank you all for attending. I would like to introduce our speaker, Brett Lutz, who is a lead forecaster at the Medford National Weather Forecast Office. He is also an incident meteorologist serving incident management teams for wildfires. Brett is also the fire weather program manager at the Medford National Weather Service Office. Thank you again for joining us. Enjoy the program, and now here's Brett.
Okay, well, yeah, my name is Brett Lutz, and I work at the Medford National Weather Service Office, as you heard, and yeah, it's preseason for fire season. I actually shouldn't even say that. Fire season has been declared in Jackson and Josephine counties based on the Oregon Department of Forestry's assessment, and believe that it was declared on May 12th. And east of the Cascades, I had heard they were going to do the same on May 15th. I didn't get any confirmation one way or another on that, but fortunately, we are in a cool pattern at the moment with some showers around. And just 15 minutes before this started here, we had a pretty good smattering of hail here, enough to cover the ground. And yeah, got a lot of kids wet up at the middle school track meet. So my presentation this evening is kind of a broad area, but we're going to talk some about lightning and some lightning climatology that we've been working on in the Medford office, and some of the weather patterns of fire season, mainly the higher impact ones, but I will talk about some other ones, and then what it's looking like for 2021. I just started with this image of a lot of really good piles being created and getting ready to burn up in the Siskiyou Mountain Park near Ashland, where they're doing a lot of work to clear out the undergrowth, but some of these piles have not been burnt, even though I think the intention was to burn them this spring because of the dryness. So anyway, that's been interesting. So looking at our overview, mainly we're going to be talking about the common weather patterns during fire season. Again, mainly the high impact ones of lightning, and then we'll touch on lightning climatology, the infamous east wind events, and then another one that tends to be problematic, dry, unstable conditions. And then we'll touch on the current drought situation and the 2021 fire season outlook. Okay, so starting with something kind of basic here. So I should say that during most of the summer months, we expect high pressure in a general sense to be located over the Four Corners region. So that's where, Utah, Colorado, Arizona, and New Mexico meet. And so in this first schematic, that high has gotten bumped eastward. Now, what's interesting is, we're in a current pattern right at the moment that looks probably a bit more like the one that you see here, but obviously that's a change from what we've been seeing, which we will discuss. But the main thing I wanted to talk about is, in the summer, the weather patterns don't move a whole lot, but when they do, those subtle changes can be significant. And so a blocking high pressure system that gets bumped out by low pressure moving in can be problematic. But in this schematic here, notice how the jet stream, which is the blue line around the low pressure where it has some rain cloud looking things here, the flow would be coming in from the southwest, so going off of, from the Oregon coast or off of the Oregon coast up into Vancouver, British Columbia, that kind of area. And that keeps weather systems moving along from the Pacific when we have that kind of flow, and just generally we end up in a southwest flow. But if we're looking for lightning, most of the time when we get significant lightning, especially dry lightning and lightning that's problematic for fire season, when the vegetation is quite dry, we'll get one of these lows that'll dip in a little further, and a lot of times what it'll do is it'll turn the flow from the southeast. So it comes up from kind of the desert southwest up along the Sierras through the Great Basin, and sometimes California. And when we have that kind of moisture feed, that's our real lightning pattern, especially our problematic dry lightning pattern across the area here. A lot of times these areas of thunderstorms that are associated with the monsoon, for us, they do produce some rainfall, and in other places they don't. But the main thing is they can produce a lot of lightning. And if the state of the vegetation is dry enough, obviously it can start fires. You look down here at the lower right, and this omega block pattern is kind of, something between that and the one above it is really what would generate, the southeast flow that we're looking for. I was having a real tough time getting a good negatively tilted trough showing up where we had, southeast flow ahead of it. But yeah, so I'm going to have to be looking for one to improve my slide deck here. But I wanted to kind of, really move on to lightning climatology, because I think this is where, there's maybe some new news or relatively new news to share with people altogether in terms of lightning across our area. Lightning is an interesting thing in that, a lot of weather data in a general sense is available, like temperature and precipitation information is available from the national, well, let's see, now they're calling them NCEI. So the National Climate and Environmental, oh boy, I'm massacring it, NCEI. It used to be NCDC, which was the National Climatic Data Center. Anyway, you can get lightning data from them, but lightning data altogether is something that is gathered by some private companies out there, like this one, Vaisala. And we've tried pretty hard to have a consistent lightning record, with consistent sensors out there to detect lightning. Anyway, so we built this climatology, a couple of forecasters at my office, Shad Keen and Charles Smith. So 1995 to 2018, the average number of lightning strikes, and you see a map here up in the upper right-hand corner of a portion of Southwest Oregon and Northern California. And Northern California, our counties of responsibility there are Siskiyou County and Modoc County. And then we have these other counties up in Oregon, Jackson, Josephine, Curry, Coos, Douglas, Lake, and Klamath counties. And so overall, our lightning climatology, maybe not a whole lot of surprise here, that lightning in our area, typically, we over time, when we've counted all the cloud to ground strikes in this database, July comes out, on top, and August 2nd. What I do think is notable is if you just look at like April to May, there's a huge jump in lightning that occurs from April to May. And then there's another huge jump from June to July. And, it's seasonality to a large degree. And obviously, this is why, with the combined dry vegetation, why we have so many problems with fires in July and August, and then lingering on into September. Now, lots of information to look at here. So this is our lightning climatology for the same area. And I apologize that these graphics are not, wonderful. Not being in the office all the time, I don't have the same access as what I have when I am. and time in the office has been a little limited with COVID and whatnot, aside from when we're on our forecast shifts. But here is the main point. So if you look at May and the May hotspot, basically what we're indicating is hot and cool areas for lightning climatology relative to other locations. So blue would be an area where we have significantly less lightning than the areas that are in the red, and the red are the areas where we have a lot of lightning. So and if you want to see just kind of a density plot with colors on it, just look at the graphic below. So for the month of May, you might pick out the counties a little better on the maps on the lower portion of this graphic. So I do find it notable that for Jackson County in particular, May is really a hot time for lightning relative to other times of the year. And it does seem like, every May or pretty close to it, we do actually get, some thunderstorm activity here. It's the changing of the seasons, and we actually have enough moisture to support the shower and thunderstorm development, kind of like we're getting now, except that we're not getting thunder out of this current system, just rain and hail and snow. But anyway, the point is that, here in May, you can see west of the Cascades, there is an enhancement, and also very notable that there's a lot more in Jackson County than Josephine County during the month of May. We go on into June, and the main area of focus tends to go more toward, let's say, Mount Shasta and areas south and east of Siskiyou Summit, and down into Modoc, portions of southern Modoc County and the east side. And so in a relative sense, we don't see as much here in Jackson County. But what is interesting is you see this little kind of nose coming up from Siskiyou County, Shasta Valley up in, and Scott Mountains up into Jackson and Josephine counties. And I think that's the time when we start to see some southeast flow get pulled into the mix. Let's move on over to July. It's kind of similar, except that things have grown a bit, north and maybe westward from what we see in the climatology for June. And then August, interesting that maybe if we're going to imply anything, there's a bit of a tendency to focus things a little further north and west, which I think would suggest that a lot of times by the time we get to August, maybe we have a little more of a influence of the Pacific Ocean at times. And September, interestingly, you'll notice that the overall lightning does tail off to some degree, but there still is some there in September. I think, as a general rule, we tend to say it's pretty rare for us to have a significant lightning outbreak after Labor Day in our area, just due to seasonality and things that come with the changing of the seasons. Daytime versus nighttime. Now this is pretty new in terms of these graphics, at least for the nighttime one, and we really haven't, I don't think, done much press with that portion of our lightning climatology database. But just doing a little math for you, because I know these are a bit technical. When we talk about daytime flash density, we're looking at the concentration of cloud to ground lightning during this time frame, which in the summer, the daytime, what we're calling that is actually noon to midnight. So, maybe not what everybody would call daytime, but noon to midnight. So what you see is there's definitely some hot spots that we tend to see quite a bit when we're making our weather forecasts, which is down in this Scott Shasta Valley interface area. I think a lot of times we have southerly flow that can get going here in the Shasta Valley, coming up from the Sacramento River drainage. And the Marble Mountains tend to block the inward intrusion of more stable Pacific Ocean marine air into the area. And so we do get some pooling of surface moisture and some heating there. And sometimes Mount Shasta sends some ripples into the mix that provide some interesting extra lift. Another hot spot is north and east of Crater Lake, up in the Chemult area and toward Newberry Crater. We tend to see a lot of action. Some other areas, you go kind of, well, really east of the Cascades, there's some hot spots, but down in the Warners, kind of training off of Lassen Peak and into the southern Warners tends to be a hot spot during the daytime. Interestingly, we talk nocturnal, so we're talking about thunder and lightning that occurs at night. I would generally say I do believe that these are going to be midnight to noon time frame. So altogether with shower and thunderstorm development, there tends to be a lag time between the maximum heating and what is kind of generated from that. But then the nighttime action, it's a interesting beast, I will say, that is not well understood. But we certainly have had times like in 2009 when the Douglas complex kicked off, in which we had not a ton of lightning, but let's say I think it was like 70 to maybe 100 strikes in Douglas and northeast Josephine, northwest Jackson County. We had that lightning in the middle of the night, and it really wasn't in the forecast either. And it came with very dry vegetation and sparked quite a number of fires, little to no rain associated with it. So let's look at that nocturnal map. Well, the Oregon Caves area, southern Josephine County, northwest Siskiyou County, and Curry County, and even really up the Coast Range. I mean, that's where we have a higher probability of seeing that nighttime thunder. Yes, there still are some hot spots out there over Klamath County, so don't want to discount that. But if we're looking at overall hot spots, it's pretty interesting to see that at night in portions of the area, particularly Josephine County, there's a relative hot spot there. Okay, so one more thing to beat on that one a bit. So this is a new graphic that was given to me by the guys doing the lightning research, and so I probably can't explain it as well as they can, but right here you see circle size proportional to fire size. Okay, so the circles are fires that started, so they're using a fire database there. I wouldn't worry about these dash lines too much, but I will tell you that there are fire weather forecast zones, and so that's why they are there. And the orange area is an area where the nocturnal storms are favored relative to other areas. So once again, you see that that southern Josephine County, northwest Siskiyou County, northern Del Norte is a location where it is favored. And I have to say, it's pretty interesting. I do remember camping just in the last few years down at Jed Smith Redwoods, and sure enough, it was in the forecast, but it wasn't the greatest depiction of it. It was a sneaky little bit of lightning that came up from the southeast and came very close to getting into the redwoods, but it didn't. Anyway, so that was just one of those events. Okay, so lightning. Yeah, we could talk on and on about it. And the one thing that I failed to produce a slide here about it is really kind of how lightning forms. So I'm going to talk about that briefly here. So overall, as far as I understand it, with lightning, the way it forms is that when you have a cloud that has a significant updraft, you end up with both water and ice. And the ice and the water tend to be in different locations of the cloud. The ice, obviously, most of the time higher up, except in the downdraft where some of it's getting pulled down, especially if you have hail. And then you have a different charge that's associated more with the water droplets. Well, basically that charge differential, where you have this positive and this negative over time, it gets to the point where something needs to release some energy. And so basically you have these ice particles up in the cloud that have this negative charge, and the negative charge wants to basically connect with other areas of negative charge toward the surface. So it basically forms a conduit, which is the lightning bolt, where the charges basically are releasing some of the potential energy. Now, I encourage you to look it up online. Wikipedia, I tend to find to be a great source, and I apologize, I don't have a more thorough explanation with a graphic for you on that, but you know, basically it's trying to equalize a building up pressure difference. Now, interestingly, when we talk about lightning, there, you know, I was going back through our lightning events from 2020. And in 2020, we had one where we actually over forecast the amount of lightning expected, especially west of the Cascades, by a fair amount. We ended up putting out red flag warnings because things were critically dry, hadn't rained in, I believe, a couple months. And, you know, any lightning was really going to be a problem because at that point, we had just had the lightning outbreak down in California that kind of scraped us with the remnants of it. But you know, California, all the resources for firefighting, or many of them, were heading to California. Well, over here on the right, you see a depiction of some high resolution weather model data where the different colors, we call it the paintball because it looks like, you know, a bunch of paint. Where you have more color, there's a higher probability of lightning. What this is actually depicting is simulated radar reflectivity and some most unstable convective available potential energy kind of in tandem. Well, anyway, the bottom line is that this lightning really didn't pan out very well. And what was interesting about it was that it was largely because we had a lot of smoke pushing up into the area from the fires in California at that time. And what we've seen over time here, especially in, you know, recent years, I guess we've observed it more, is that when we have significant smoke on or near the ground, it can disrupt the formation of thunderstorms, you know, when we're expecting them. Generally speaking, the smoke acts like additional condensation nuclei that basically causes the water droplets to be spread out over kind of more of a horizontal plane instead of being able to focus more into consolidated updrafts for single clouds. Altogether, the other thing is a lot of our thunderstorm events, moisture is really the thing that we're low on. And the other part is that you need to have surface heating. So if you have smoke, you take away some of the surface heating, you increase the condensation nuclei, and you spread out those water droplets. And so a lot of times the potential is not realized. Now, we do have some events where we will get some lightning, and those are the ones that we say are strongly forced, meaning that the impulse moving through is pretty significant rather than subtle. So right here on the left, what I have depicted is a portion of our area forecast discussion that we had made prior to this event. We had put out some red flag warnings for the potential of abundant lightning, but in our area forecast discussion, we often talk about the subtleties of the situation. And this one pretty much nailed it in advance that the smoke was going to limit the potential of the lightning event. Now, we did end up having some lightning out of this, just not nearly as much as expected. In fact, I think west of the Cascades, it was like one strike in Josephine County and not much of anything in Jackson County. All right, well, I have to say every time I see this, the east wind event of 2020, I kind of cringe a little bit just because, yeah, it caused a lot of destruction. And it's a little interesting. I'm looking at this graphic right now, and I'm going, well, the one that they say was Alameda here was actually the Oban chain fire, so that's a little interesting. And the one that you can barely see, that where there's a little bit of red here on the bottom of the screen, that would be the Slater fire. Um, and the Alameda Drive fire, which started near Ashland and made its way down to into Phoenix and started to get into the southeast Medford area. That's not, excuse me, it's not on here, but boy, what a tremendous amount of smoke was caused by that. And we're going to talk a little bit about these events and that event in particular, which was definitely a high-end climatological event, meaning the return interval is pretty low. I spent a couple weeks on the Archie Creek fire, helping with containment efforts on that, just in terms of providing some detailed weather information up there. And these fires, I mean, you just go on up the road here, Holiday Farm, very destructive fire, Beachy Creek, Lions Head, Riverside. In terms of damage, certainly we have not seen things like that in Oregon in the last 15 years. So I did grab some slides from some other folks in the Weather Service here, but the thing that's nice about these is that they do generally show overall, what kind of thing does happen that creates these east winds. So sometimes it comes on the heels of a big low pressure trough. So if you look here at the little dotted lines or in the white triangles to the east of the high pressure there coming through Idaho and coming down and edging near Utah and into Nevada, basically there's a low pressure system out there that has dove in from the north across the Rockies. It could come in from the Pacific Northwest. But in the wake of a strong low, you often have a strong high pressure system. Different areas have different names for these winds. So probably the most infamous would be the Santa Ana down there in Southern California. You get into Central California, and the Diablo winds is one name for them. You also see mono winds. I think in the Redding area, they tend to refer to them as north winds because they come down the Sacramento drainage. And up in our area, it's just very simply east winds, naming them for the direction where they came from. But they're the same thing basically as a phone wind or a Santa Ana wind or a Diablo wind, where here on the graphic on the left, basically the subsiding air, the air going downward due to the laws of physics, basically causes the air to warm and dry as it comes down the mountains. Basically, it leaves its moisture for the most part, or a portion of it, on the upwind side of the mountains. When it hits a coastal range, it dries and warms even further. So, here in Oregon, I mean, people who aren't living here or from here, don't know too much about geography, maybe don't realize that we have many mountain ranges, and we have, the Cascades that kind of merge into the Sierras to some degree. And then we do have our coastal ranges and near coastal ranges as well. And so, we get a similar effect of the warmth and dryness. And, a lot of times these are more common. The strong east wind events are most common climatologically in the fall months of September and October. And in recent years, we've seen them also in November, causing the havoc in Northern California the last, some of the last several years. And altogether, one of the questions is, are these events increasing? Are we getting more of them? Are they more destructive? And, research is underway in terms of that looking into that. What we're looking at the Weather Service office is the return intervals of these events. I mean, they've occurred, but they've occurred in the past and they've been strong in the past. But I think what's really getting us is that at times, like in, I believe it was 2017 and 18, we saw more of these winds in the middle of the summer than we typically do. And so that was problematic. And then the other thing that we're seeing is that it's taking longer for the fall rains to come. And also we have seen here both last year and this year a tendency for these east wind events to occur more in the spring, and we're getting less precipitation. Basically, it appears that at times, the length of the dry season and the length of the fire season, which obviously are kind of they're very much related, is getting to be larger, especially when those rains either end early or come late. Okay, I bet we're all ready for the next slide. Okay, so our next fire weather pattern, I have this thing that says Haynes 5.6 on it. And what I wanted to talk about in terms of what does that mean? Well, we have an index called the Haynes Index that measures dryness and instability in the lower atmosphere, but above the surface. And basically, we're measuring the difference in temperature in height from two different levels, and also the amount of moisture in a critical layer above the surface. And when it's really dry and it's really unstable, basically that's when the Haynes index is a 5 to a 6. It's on the high to very high end of things. And, if you get a fire, it can be really problematic. This thing about the thermal trough. So sometimes when we get those east winds and from the high pressure kind of causing the winds to come across from the east, it forms a kind of like a heat bubble downwind of the mountainous terrain west of the Cascades and west of the Coast Range. But when the pattern shifts, that heat bubble, that dry, hot area that was generated from the downward flow of air from the mountains, basically that pool of air moves back over the area before it departs. So that's what I mean when I say usually with the thermal trough. So you've got that dry, hot air moving across the area, and it can really be the recipe to cause fires that exist to blow up, or ones that haven't formed yet to grow quite explosively. If the state of the vegetation is not dry enough, it's not a big deal, because we can control those fires with the firefighting resources that we have at our disposal. However, if it's very dry, then it's problematic. And this particular image, the Souts Creek fire east of Canyonville, July 30th, 2015. That was somebody, as you might remember, mowing their lawn and mowing dry grass. And this fire just basically went from 0 to 60 and just kept on going until it was basically creating a pyrocumulus that turned into a thunder cell. So, one of the parts of smoke is it's releasing water vapor from the vegetation. And if it goes high enough, gets forced high enough by all of the heat, it will form a cloud. And then that cloud itself can actually create the charge differential to cause cloud to ground lightning strikes. Obviously, the other problem is that it's lifting embers, and sometimes even limbs and whole trees off of the ground, sucking those up and tossing them out in front of the smoke plume itself, or dropping them out of it and basically creating new fires out in front of it. In this situation and many others where we have this Haines 5.6, you're also looking at a critically dry air mass with single digit relative humidities. So, it's a core of a fire season kind of thing. Most typical in July and August, where we have strong surface heating and dry conditions occurring together. So moving on, and like I said, some of those topics, boy, we could do a whole hour on each one of those. But we'll move on to the fire season outlook. But with, we've got to kind of preface it with what is our current state of affairs here. So the North American Drought Monitor is quite shocking for the Western United States, I would say right now. Altogether, it's a bit of a, I mean, you're going to have some water issue kind of stuff going on in any water supply issues or effects to the flora and fauna of our forests and rivers and whatnot, even into the ocean where where the runoff might be reduced when you start to get into the abnormally dry. But moderate drought, water shortages can be happening. The impacts start to increase. Severe is when you're pretty much expecting to have water shortages to one degree or another. Extreme means that it's a pretty rare return interval event, and altogether, not something we see very often. However, in more recent years, maybe have we been seeing more of it? Well, we did have the drought in 2013 and 2014 that was pretty severe, followed by a snow drought in 2014 and 2015, where while we had normal precipitation in this area, we had very little snow. And the snow serves as a reservoir for us that slowly basically melts into the water systems, both above and below ground, that feeds our water supplies. So obviously, the drier, the worse it is. And I'm sure many of you have heard about the situation in the southwestern US where, shall we say, is kind of becoming the day of reckoning about all the growth that's gone on in those areas over the years. And the Colorado River is not doing well in terms of its water, and a lot of the lakes are having some issues there. Exceptional drought, means that in our historical record, which I'll say generally goes back to the 1880s, it hasn't been seen before. Now, I know that we've definitely got some scientists on here, and if you have been reading up on things, you'll also know that tree ring evidence does suggest that it hasn't always been so wet in the Southwest, and there's certainly a history of drought. And so I think that overall the drought depiction here is showing us the potential impacts of the water shortages that we're seeing, the current impacts, and overall effect on the ecosystems in those areas. So a pretty serious situation down in the Southwest right now. And oh, by the way, Klamath and Lake counties, I believe this is the first time that there has been a D4 exceptional drought depicted in Oregon in, I believe, 10 years. So pretty rare. And for these counties, it may be unprecedented. If you want to look further into the history of drought, I will direct you to the US, so United States Drought Monitor, and they do have an archive on their website where you can actually animate the graphic of this sort. Yeah, I could go on and on. the one other thing I will say is that we do live in an area that has a lot of climate variability. Areas to our south tend to have another thing that happens where they get a lot of their precipitation in short bursts. And, are we seeing that progress northward? Well, many do believe that we are, and we also are concerned about, drought being a more significant issue over time. And the reasons for that, of course, are climate change. So, the gradual warming trend that we've seen in the climate record globally for the most part, and also that we're seeing increasing water demand or demands on our water systems. Okay, so let's talk about more how we got there this year. Interestingly, if you look at from October 1st through the end of April at temperature, this is in degrees Fahrenheit, and the coloring starts when you're a half a degree Fahrenheit from what the 1981 to 2010 normal period said was the average, basically. So we're looking at average temperature over this whole time compared to the 1981 to 2010 period on the graphic on the left. This West-wide drought tracker is available on the internet, and I encourage you, if you're interested in this kind of information, to check it out. They have a really nice archive as well. Very nice data set altogether. Interestingly, so this wet season, I'll say, so the wet season begins October 1st, the way we do it here. Temperatures, while they have been above normal in Southwest Oregon, you can see here that generally speaking, they have been on the order of 1 degree Fahrenheit or less above normal. A little higher in some areas, a little less in others. And I believe it's mainly October and April that contributed to a lot of this warmth altogether. But yeah, the core months of the winter, we did have our La Nina. We did surge up to 90% of normal snow water equivalent around the time when the snowpack usually peaks in mid-March. And things were looking pretty good until, boom, we hit this outrageous dry spell that we're currently in. Anyway, where do these temperatures rank in the long climate record, 1895 to 2010, with a footnote that we're missing 2010 to 2020 on this graph. Hopefully that will be added soon so we can see it in terms of that kind of ranking, because, well, there have been some warmer years there of late. And so if we're going to say record warmest, well, we probably have hit that 2010 to 2020. But good period of record to compare to, in that it encompasses the whole climate record. And so even with being not that far from normal relative to the longer term record, it has been in the top 33% of climatology for much of the area. Okay, I'm going to try to accelerate a little bit on the outlook here. But what you'll notice is for precipitation, actually some areas in Del Norte and Curry County up through the end of April were pretty close to normal for precipitation, but the rest of us, for the most part, are below the normal. What I find a little interesting about this year is that, up until mid-March, while we had some deficits, it wasn't terrible. The snowpack was all right, but then we really missed out, and our water situation is pretty bad because you combine those warmer temperatures with the lesser precipitation, and obviously that increases your evaporation of what water and moisture you have. I do want to just point out for you that we do have a product on our website. So this is our weather service website, weather.gov, Medford, and you can get to this page. If you click on this map, you get a forecast for the point where you clicked, and you can move that little point around. It will work, all throughout the country from the various offices. But the main thing I want to point you to is if you're interested in looking at climate data in the past. So we have these monthly climate summaries, and then we have the outlook for the next month. And we try to update these in the first half of the month. We shoot for about the 7th, but there aren't too many people doing this. It's really me and one other person, and we do them as we have time to do them, and just try to keep on it. So I'll show you a little bit about that. So for instance, we're looking at April. We have the Climate Prediction Center's forecast here on the left that they issued on March 31st. And we issued basically a bit of an update on April 9th to that, where we said, okay, well, it's been pretty warm so far this month. What do we think it's going to be? Well, we basically said, aside from the immediate coast, we think it's to be above normal this month. Well, yes, we had a leg up on them because we didn't have to do it until April 9th, because that's when we got to doing it. But there was a lot of abnormally cold water along the coast, which I'll talk about a little bit more as we move forward. So that clued us to the cooler temps for portions of the area there, albeit very much confined to the coast, generally speaking. And it was quite a above normal month. Sometimes, just 1 week into it can really tip you off to what's going on. But we were able to pick up on the fact that no, it wasn't going to be cooler than normal for most of the area in April by about the 9th. Yeah, so like I said, I want to move along a little more. If we're looking at April precipitation here, our outlook does that as well, where we basically look at the Climate Prediction Center, where they said equal chances of above, near normal, and below normal precipitation. But yeah, we were 9 days into the month, and we were pretty definitively able to say high confidence of below normal precipitation across the forecast area in the 0 to 50% range. Southwest flow in the last 10 days of the month could bring some activity. Well, that's what we got. That's why we had a little closer to climatology out over portions of the area east of the Cascades. But you can see it ended up pretty dry. So if you're looking for, maybe a little more beyond the Climate Prediction Center's forecast, keep an eye out for these. And we do archive them too if you're doing some kind of project related to it. May so far, well, it's been cool east of the Rockies, at least out in the plains, but warm out here in the southwest and west coast areas, except along the immediate coast. And we're almost going to get there. Precipitation, yeah, this doesn't include what we got yesterday and today. Yesterday and today, some areas I noticed, 1/10 of an inch or less for most areas, although there were some areas that got up around 1/4 of an inch. Everything helps, but in terms of really, making a dent in the drought, we're not doing that. We're just trying to keep up with climatology at this point, even just on short time scales, such as like a day, a week, or a month, and hope our deficits don't grow anymore. Okay, so all in all, we made a May update as well, and you see the Climate Prediction Center had this little bit of above normal temperatures. Basically, we're sticking with the idea that along and near the coast, where there's colder than normal water, that it's going to be cool there, but it looks like it's to be above normal, even though it's pretty cold relative to climatology both yesterday and today. Generally, the month is likely to end above normal. Precipitation wise, where they have this, their probabilities of below normal precipitation. Yes, it's difficult when it's hit and miss convection, but we're pretty confident. Again, we're going to end up below normal for precipitation, except for some areas east of the Cascades where there are indications that this upper level low is very much going to stall out and provide multiple days of showers and mountain snow across that area. So anyway, moving on to finally talk about the overall pattern we've been in. So this graphic on the left indicates generally pressure and temperature compared to normal for the October 1st to April 30th timeframe. And what are we calling so-called normal? In this case, we're talking about the average conditions from 1981 to 2010. And altogether, you'll notice that across the Pacific here, we've had warmer conditions and more high pressure out in that area. Up over Northwest Canada, more of a cold trough. And what that equates to is more of a northwest flow for us, which is fairly typical of a La Nina, albeit this one, I would say the high pressure is bumped in a little more to the West Coast than what some of them result in. And what we've been seeing, especially this spring, is high pressure sitting in the Gulf of Alaska, and blocking the storm track from there. And the water, due to the high pressure and, not a whole lot of cloud cover, has been pretty warm there. Also, we're getting warm water coming, from the Western Pacific. But where we've had the northerly winds along and near the coast, the net transport of water due to the thing that we call the Ekman spiral principle sends water to the right of the mean wind direction on the ocean surface. And when that water moves away from the coast, water needs to come up from the depths to replace the warm water. So we've been looking at water temperatures for quite a little while here, a month or longer, where along the West Coast, water temperatures have been very much below normal for this time of the year, in the mid 40s to upper 40s along the Southwest Oregon coast in particular. The upshot of this is cooler conditions when the flow is onshore, but mainly that's been mostly happening just for the coastal counties. Coos has been catching it more than Curry because Curry's so mountainous and whatnot. So the Weather Service, overall, we get asked to do a lot of fire season outlooks, and predictive services, which we do work with, but they are located, there's one office in Reading, for instance, that we coordinate with, and one up in Portland. They make the fire season outlooks. We often are asked, what do we think? Are things going to differ based on what we're seeing? Well, I'd say for the month of May, they've got it pretty well pinned. The Southwest Four Corners area has been seeing some significant fire activity already. And the projection for June is that it's going to get up pretty close to us here. But you can see that they don't have it into Southwest Oregon for above normal significant fire activity. What are we looking at? And I'm sorry that this came out a bit blurry. I will explain to you what we're looking at. Yes, there's hope for a June reprieve. Is that reality? Well, no, not yet. But we can hope, right? But yeah, I mean, we're in this drought situation, and this is the European model data from 2 days ago, where when we look at the 30-day departure from normal projected by this model for basically the month of June, so it's 30 days ending July 1st, it's indicating a net positive, above normal precipitation is what I'm trying to say. It's not that hard to say, but what I also thought was notable is it has above normal temperatures as well. So warmer and wetter, well, it's probably better than warmer and drier than normal, but will we see it? Well, when I took a look at this is really projected to be mostly in the 2nd to 3rd weeks of June, and that's pretty far away. So we'll just have to see how it pans out. I did think it's, you know, this model is picking up on the cool temperatures along and near the coast. And so that's definitely, you know, showing you that it's tracking what's going on reasonably well. I took a look at it today, and it's not as robust with the, you know, moisture signal there. But what does the Climate Prediction Center say? They update their forecasts the 3rd Thursday of every month for the next month. And here is what they have. So a lot of equal chances for us for precipitation. They're calling it kind of a toss-up for Jackson-Josephine County, and some increased tendency for above normal temperatures, except right along the coast. So these forecasts are somewhat consistent. I think overall what you're seeing is that they don't have as much confidence in this precipitation, and you know, when we're in drought, yeah, there's reason to be pessimistic about the precipitation situation going into the dry season, and knowing that we're already in drought, and so there's less evapotranspiration to feed the clouds as they try to grow. July, August, September. These long-range forecasts tend to be mostly based on long-term trends, in particular on the temperature. So you can see a greater than 50% probability for those 3 months combined of above average temperatures. And yeah, it's pretty likely. I can tell you that in doing those monthly outlooks that we do and then verifying them, we're pretty much in the situation where I would say between 8 and 10 out of every 12 months we end up with above normal temperatures these days. So if you're playing the odds, you know, forecast above normal temperatures. Sometimes we do get cool months, single months in the mix, but overall the tendency is warmer than normal. Precipitation wise, it is a little interesting that there is this equal chances for precip. There's some kind of signal that maybe we get a little more of a westward shifted monsoon. I'm sorry, I flipped the slide by accident, but yeah, time will tell. What does the European model say about the July, August, September timeframe? Well, it says a little bit above normal for temperature. And these again, believe, I'm looking for my label. These are actually degrees. This is a degree Celsius anomaly. So 1.8 degrees Fahrenheit per degree Celsius. So where you see this brighter shading, you're looking at like 2 degrees Fahrenheit. And so anyway, the overall idea is it's indicating above normal temperatures, not you know, terribly above normal, but when you're looking at a 3-month average, 1 to 2 degrees is notable and increases your water demands. Looking at the precipitation, you can see that it, you know, we don't expect a lot of precipitation during the wet season. I mean, the dry season. The wet season we do, but the dry season we don't. But you'll see that it's indicating pretty close to near normal. Yeah, so that's what we expect at this point. So how does that translate into fire potential? Well, this is where I scratch my head as a Weather Service guy and say, yeah, July, I guarantee you I have some concern for July this year for above normal activity. Now, we do expect fires to begin in July, ones that can become problematic, but you know, given the preceding drought conditions, it's very much with the projection of above normal temperatures and the fact that we're in drought. Really, we're just short of ignitions and the actual weather at the time to you know, as the variable. So I have concern about July being above normal. And you can see for August for fire activity, the current anticipation is for above normal fire activity. There currently aren't September, October outlooks out there. I can tell you that the models are suggesting maybe we get a little more moisture than normal in here in the fall. But we're going to be pretty dry at that point. So I would just say prepare for the worst and hope for the best. Yeah, and on that note, I'll see if there are any questions, but we do have some contact info here. And yeah, my message for fire season is really at this point, try to get on the protection of your property and reducing those fuels, making your properties as fire safe as you can with what time you have, because it may pay off this season or it may pay off some season down the road, but the reduction of potential fuels, especially in those critical places like in your gutters and close to your home, is pretty critical to minimizing fire risk on your property. So with that, I'm going to stop presenting. Thank you for your attention, and I hope it was useful to you, and we'll see if there are any questions. And I'll see if I can give control back to Jerry here. Okay, it looks like we're good.
Thank you, Brett. We do have some questions. Kathy from early on wants to know what the years that the hotspots and density charts were created.
Okay, so that, of course, is a great question. And I do believe, let's see here, one of these, see if I can find that out from my charts. Oh boy. Yeah, so I do believe that the lightning data that we're looking at is 1995 to 2018. And so that's what that's currently built off of, 1995 to 2018.
Great. I think Willow may have answered that in the chat a little bit later. Charisse asks, she has a time span question as well. For the monthly lightning density map averaging, she wants to know if it's 100 years and if it has changed over the last century.
Okay, so those those density charts, again, those are only 1995 to 2018, and yeah, for lightning is an interesting one because, for one, the period of record is relatively short. I do recall coming upon some lightning data going back to maybe, I know it was at least 1990, maybe into the 1980s, but lightning data in terms of records that I'm aware of, it doesn't go back past that time frame. So looking at lightning more than 100 years or even 100 years back, I don't think that data exists. You know how scientists can be pretty creative, and possibly there could be some simulations, but I think lightning is complex enough that it probably doesn't really exist. What does exist that I think is maybe helping us with past climate is looking at tree rings, so dendrochronology, where we're looking at the size of the growth rings, and that tells us a fair amount about past drought conditions. So hopefully that kind of answered the question. I'm sorry I couldn't fully answer it, and I'm sorry there isn't more lightning data for us to look at. I do want to say actually one more thing. In terms of overall lightning trends, up at the Northwest Coordination Center in Portland, I know they have looked at lightning trends, and as far as I know, they haven't noticed an overall upward trend. There was a year here in the last 5 years that was the greatest amount of lightning in the Pacific Northwest in their database. So that does say something, but then there were some quiet years on the edges of that. So you know, we don't actually really know what the current trend is based on the data that we have.
Okay. Alan asks, is the changing climate causing any changes in lightning density or temporal spatial distribution? Hey, Alan, Brett, I think we're not hearing you.
I'm sorry, you're seeing me talk, but you're not hearing me talk. Let me try again. So the most simple way to answer that is that, to my knowledge, we don't know at this point. However, I also think it would be we probably should expect that there is some kind of change. One year when we did have a lot of lightning, the water temperatures offshore were warmer than what they typically are. And so overall, the dew points from the air that was drawn in from the Pacific were higher than what they typically are. And so for that particular fire season, it may have increased the amount of available moisture that then could result in lightning. However, there are kind of two things that go with the lightning. One, you have to, well, actually three things. So you have to have the moisture and you have to have the instability, but then you also have to have a trigger, and the trigger is some kind of impulse aloft to aid in the lifting, which is usually a cold weather system over the top. So, I'll leave that one for the researchers, and we'll see if we can learn from them.
Nona asks, have you seen any effect of the Colorado River watershed climate modification program?
I have not. Yeah, so I have read a fair amount about the Colorado River and the situation in terms of the dams where many of them are filling with sediment, and that the water demands on the river are more significant than what the river's been able to produce. But in terms of modification, no, I have not.
Wendy is wondering if you have a graph showing the length of drought years and how many lightning strikes occur as to when we have wet years, and I guess correlating lightning strikes with wet years and dry years. And then again, asking how far back that goes.
So we do not have such a graph or a chart, but I will provide some anecdotal information in terms of drought and lightning. So one thing that my fellow forecasters and I have noted is a lot of times, it seems like most of the time, when Northern California is in a drought, we tend to see more of the thunderstorm events end up with lightning amounts and overall convection, meaning showers and thunderstorms, being lesser than what is expected. And I think what it is, the model guidance assumes a kind of normal state of affairs. There are a lot of weather models out there now, and so they're not all quite the same. But when you have less moisture available in the vegetation and from the surface, you have less moisture available to lift into convection. So, what is interesting, I know I gave kind of like a dire, to some degree, look into our drought situation. We have had years where we have been in drought and we just don't have that much lightning, little to no lightning, and then we end up with a few fires. And I can't remember exactly what year it was, but definitely we've had that happen here in the last 5 years. So, you know, correlating the lightning and the drought, it's an interesting one because I'm not sure that the correlation is all that strong. It might even be a reverse thing where if you have less moisture available, you're going to end up with less convection. However, once again, one for the researchers to check out.
Well, thank you, Brett. The rest of the comments are thank yous. If anybody else has any questions, I guess at this point you could ask them in the chat or even unmute yourself and ask them personally.
Okay, I'm hearing nothing and seeing
Yeah.
nothing, but I will tell you, you know, a lot you asked a lot of great questions, and one thing that you know, I meant to do early in my presentation is to say that you know, we get asked a lot of questions, and I like the questions. They're thought provoking. We spend a lot of time with operational meteorology and basically forecasting the weather here in the short term, and then you can see going about a month with some interest in the longer range. And there are many scientists out there who are digging into these things, you know, more and more. I uncovered a paper today that says it's from 1957 frequency of dry east winds over this area. And you know, there's a lot of information out there. Just always check your sources, make sure that they are, you know, ones that can defend their science with data. And really, that's when I'm looking at stuff like that. That's really it, because you know, you can get a lot of false information if you're looking at the wrong thing. But if there's good data and science behind it, well, then it's defensible at least. Thanks.
Thank you very much, Brett. It was very informative and enjoyable.
All right. Thanks, Jerry.
Yeah, I guess that's all.
Thanks a lot. All right.
Thank you.
Have a good evening.
Yeah.
Bye-bye.